and welcome to our wonderful partnership program here at the Galbert Family Miami Beach JCC on the Simpkins Family Campus. Checked all the boxes. My name is Paul Frischman. I am privileged to be the CEO here at our JCC. I always do this when we start. Whose first time in the building is this? Please raise your hand. Wow, welcome. All right. Well, I hope you come back, and please come and enjoy. There's so many things that are wonderful to do here at our JCC. We are celebrating, if you didn't see all the signage on the walls, our 10-year anniversary in this building. And we're making a tremendous impact with everything that we do in terms of all of our cultural, recreational, and social programs. So we're really excited about putting this program together because one of the wonderful avenues of our JCC is working partnerships. And one of our wonderful partnerships is always with Nicklaus Children. And my friend back there, Deborah Wasserman, hello. I want to wish her and her husband a mazel tov. Became a grandma for the 8th time, I believe, today. Is that correct? So mazel tov to you. And you're here. That's amazing. So thank you for that. It says here, GENEuary 2023. I like the marketing. Very nice. So we're here to talk all about the genomic discovery and who do you think you are, how genomics and artificial intelligence challenges our sense of self. We have some tremendous speakers that we're going to present, one of which I was just in his hometown in Atlanta, Dr. Paul Root Wolpe, who is a Raymond, and help me with the name here, Shinazi Distinguished Research Chair from Emory University. So put your hands together and welcome to our community. And on our stage will also be Dr. Evelyn Marladine Olmsted, who is the Manager of Health Outcomes Research at Nicklaus Children's Hospital. So welcome. And also, forgive me on the name, Dr. Daria Salkina. Did I get close? Salkina. Well, help me. That's what I said. So we welcome all of our doctors and our panelists. I do want to thank my fellow colleagues from the other JCCs. We all partner together to help promote these programs, and that would be, we'll start with the Michael Ann Russell JCC, which is in North Miami Beach. We have the Alper JCC, which is down in Kendall. I started my career down there. And also the David Posnack JCC. Anybody familiar with the Posnack JCC? It's in South Broward. Cooper City, we were just talking about that. That's not far from where I live. So all of our JCCs, we work together to always form partnerships. And of course, the partnership tonight, we have a lot of wonderful partners, starting with the Nicklaus Children's Hospital Foundation, the Nicklaus Children's Young Ambassadors Program, Nicklaus Children's Hospital, Victor Center, and the Nicklaus Children's Hospital Research Institute. Did I forget anything? I think I've got them all covered. So with that said, it is my privilege and pleasure to introduce, I'm going to call up right now Dr. Dean Olmsted for the next introductions. You can use whatever you want.
All right. I'm not as good off the cuff as you are. Okay. And this one is not on, so we're all right. Okay, thank you everybody so much for joining us tonight for our keynote address for our GENEuary series. We're so excited to be here. I want to give a special thanks to the new grandma, Debbie Wasserman. GENEuary was her idea, and she has really worked tirelessly to put this program together. And I also want to thank Ms. Wanda Payton, who is not with us. She's probably with us on the Zoom, our project coordinator, for her essential support as well. So what is GENEuary? GENEuary is a month-long campaign to promote understanding of the role of genetics in health, as well as the innovative genetic testing, treatments, and counseling available at Nicklaus Children's Hospital. And it's produced by the Personalized Medicine and Health Outcomes Program within Nicklaus Children's Hospital. And that includes the Victor Center for the Prevention of Jewish Genetic Diseases, which provides screening and counseling to all families, planning a family, not only Jewish families. We do pan-ethnic preconception screening. So we offer, we do a lot of different research, bedside treatments, a lot of exciting things going on with personalized or genomic medicine in Nicklaus Children's. And part of our mission is outreach. Because these technologies are so cutting edge, because they're changing so rapidly, We really need to keep the public engaged and aware of what's going on so we can all be important consumers of healthcare, and also continuously reaching out to our healthcare providers so that they can engage in these technologies in the most effective way to benefit the most people. So GENEuary is a big part of us fulfilling that outreach and educational mission. All these events are free and open to the public. I'll just quickly mention the ones coming up. On Friday, we have Dr. Chan of Sanford Health, who's going to be speaking about biobanks and the importance of biobanks in health. Biobanks, of course, collect tissue samples for future genomic research, and Nicklaus Children's is home to one of the very first pediatric biobanks in the region. It's been very successful and already contributed to some exciting research endeavors. Then at the end of March, we have sort of a GENEuary bonus, and there we're going to be bringing some of the speakers that we host regularly for another program that we produce in partnership with Overtown Youth Center. And this is an after-school genomics curriculum for young people in the Overtown area. It's called Project Genes. And as part of this after-school curriculum, we bring in speakers from around the world, mostly speakers of color, again, to build that awareness, to get people of color more interested, more engaged. And as part of GENEuary, we were bringing in some of our speakers, one from Vanderbilt University, Dr. Jada Ben-Torres, and another from the University of South Carolina, Dr. Carlina de la Cova. They're going to be giving a presentation to parents as part of the Overtown Youth Center's Parents STEM Nights. So GENEuary doesn't end just because January does. So please, in your programs here that you have, you'll see at the beginning there is a list of all the different events. And our website, if it's not on here, we can put it up later or circulate it on the Zoom, but that has the list of events. All the events are hybrid also, the ones that are upcoming. There's a virtual option and an in-person option. So, let's see. I think that is it in terms of our upcoming programming. So without further ado, I will introduce our speaker, Dr. Paul Root-Wolpe. We're so thrilled to have him here. As Paul mentioned, he's the Raymond Shinazi Distinguished Research Chair in Jewish Bioethics. He's also a professor of medicine, pediatrics, psychiatry, neuroscience, and sociology at Emory University, and he's the director of their Center for Ethics. He's the editor-in-chief of the American Journal of Bioethics Neuroscience and sits on the editorial board for over a dozen professional journals. He served as 17 years as senior bioethicist for NASA. He's the immediate past president of the Association of Bioethics Program Directors, as well as a past president of the American Society for Bioethics and Humanities, a fellow of the Hastings Center, a fellow of the College of Physicians of Philadelphia, which is the country's oldest medical society. So he wears a lot of hats. He's engaged in many different fields. He publishes in all of these different fields and has also authored several encyclopedia entries and guides on ethical and bioethical issues. He's trained as a social scientist. Woohoo! I'm an anthropologist, so I'm in favor of this. And this is a rare background for an ethicist. And his work focuses on the social, religious, ethical, and ideological impact of medicine and technology on the human condition. He is a founder of the field of neuroethics, which examines the ethical implications of neuroscience. He also organized BEINGS, which is an acronym that stands for Biotechnology and the Ethical Imagination, a global summit, which brought together thought leaders to reach consensus on ethical principles and standards for human cellular genetics and biotechnology. And he's also been a leader in the national bioethical conversation surrounding COVID-19 and vaccine distribution. He's also very involved in Jewish bioethics and is published widely in the field of Jewish thought. In May 2019, he was the commencement speaker and received an honorary degree at the graduation ceremonies of American Jewish University. He was a founder of the Academic Coalition for Jewish Bioethics and is the bioethics advisor to JScreen, which is that other preconception screening carrier, genetic screening for those communities that aren't fortunate enough to have a Victor Center in them. He works in interfaith ethics, having recently met with the Dalai Lama to explore links between Jewish and Western ethics and the Dalai Lama's secular ethics. And Dr. Wolpe was a major contributor to a guide to Jewish end-of-life issues, Bechoref HaChaim, in the Winter of Life. He's a very popular speaker internationally. He's been chosen by the website Faculty Row as a super professor and by the teaching company as a Superstar Teacher of America. He won the 2011 World Technology Network Award in Ethics, has recorded a popular TED Talk with over 1.5 million views, and was named a top thought leader in trustworthy business behavior. as also was profiled in the November 2011 Atlantic magazine as a brave thinker of 2011. He's a frequent contributor and commentator in both the broadcast and print media, has been featured on 60 Minutes with a personal profile in Science Times of the New York Times, and now he's here with us to speak to all of you. So we're very thrilled. Please give a warm welcome to Dr. Paul Root-Wolpe.
All right? Okay. I'm totally delighted to be here. I've been here for a few days and just thoroughly, my wife and I have enjoyed our time here, so this has been a treat for me. So I give two kinds of talks. One is a coherent, lovely talk where I make some points and then in the end tie them together into some nice conclusion. This is not that. This will be a rambling roller coaster of a talk where I'm going to bring in stuff from all over the place and leave you with far more questions than answers. But I think those are more fun. So let's begin. Here's what I'm going to explore with you today, all very briefly, because any one of these could be a complete talk or many talks. I'm going to talk about how the world is changing technologically through genetic technologies, and because this is GENEuary, I'm going to talk more about genetics than other technologies. But I'm also going to say a few words about neuroscience and a few words about artificial intelligence. Then I'm going to ask what the impact is of genetics and a little bit of the other two also on the way Jews think about themselves, and then by extension how other people think about themselves too. Jews are really the example here. And we'll look at Jewish genetic identity, what that means or what it doesn't mean. Jews and genes more physiologically. And then what the term or the idea of Jewishness is in the genetic age, and then hopefully tie some of it together with a few ethical reflections. All right, so let's begin thinking about genetic technology in general. We can now engineer the human race, says MIT Technology Review, and yes, we have discovered ways to manipulate the very plasms of life that were almost unthinkable just a short time ago. I like to say to my students that I read a lot of science fiction in high school, and I like to tell them science fiction doesn't really exist anymore. Because almost all those things we talked about in high school science fiction books and read about, we're doing them. And especially in genetics. We've cloned animals of various kinds. That's Dolly. That actually is a picture of Dolly, the first cloned mammal, now happily stuffed in a museum in Edinburgh. You can go visit Dolly if you want to see. Looks like a sheep to me, but it's a Dolly. George Church, one of the great geneticists in the world, is at Harvard and says that they're close to cloning a woolly mammoth, which they're going to gestate in the womb of an elephant, which has its own issues that we can talk about. And he imagines repopulating the great tundras of Russia with herds of woolly mammoth. And by the way, technologically we can do it. Whether we will do it or not is a different question, but we can do it. The lower salmon is a salmon. The upper big salmon is a genetically engineered salmon, engineered with some genes from a pike and a couple of other fish that makes the salmon grow 30 to 40% larger than a normal salmon. And it has been approved for market. So you may be eating genetically altered salmon very soon. We can genetically engineer animals in ways that are remarkable. This is a monkey, and we've done this with many, many animals, who has the bioluminescent gene of either a deep sea coral in this case, or in some cases deep sea jellyfish, that makes these animals glow red, green, and other colors, sometimes just regularly, sometimes under certain wavelengths of light. This happens to be the green fluorescent protein, which is used a lot in medicine. But in fact, we actually could, if we have the technology, if we wanted to create a human being that glows in the dark. It might make it easier to find your grandson, but I'm not sure that that's something that we want to start doing. And some of you may have read that not a short time ago, they gestated the first lamb fetuses in artificial wombs. So think about the implications of all of this. We're able to genetically change the physiology of animals, whether growing them differently or bigger. We can clone and duplicate animals. We can we can add genes from a variety of different places. I mean, glowing green is just a really nice, very publicly flashy way to do it, but we can put many different kinds of genes into animals, and then we might be able to gestate them independently. We can't do that yet. We can't take it from fertilized egg all the way to adult animal, but we're getting much closer. We recently transplanted a genetically altered pig heart into human beings in the first surgery. That's called xenotransplantation. When we take the body part from an animal and transplant it into human beings. We do pig valves regularly, but they're not generally genetically altered. We can now actually take genetic material from human beings, and we can begin to manipulate that so that products that we put back into that human being are actually seen by the body of that human being as belonging to them, even though they are perhaps from animals, or perhaps they're blood products or other things. And you may have heard that Dr. He Zhonghui, the Chinese scientist, became the first person to actually genetically engineer human beings. He engineered a set of twins in China by altering a gene that made them more susceptible to AIDS, arguing that he was doing it to increase their resistance to AIDS, but it was seen as a violation of many, many different scientific and ethical standards, and he was arrested and imprisoned by the Chinese authorities. But in fact, he showed that you can genetically engineer human beings. And though we aren't going to be doing that anytime soon, I hope, it certainly is almost universally considered to be profoundly unethical for reasons we can discuss if you're interested. Despite the fact that he did this in a way that was scientifically and ethically unsupportable, he also happened to prove that you can do it. So, we could talk about this stuff all day, but I want us to understand that remarkable things are happening in our ability to biologically alter animals and human beings. At the same time, we're learning profound new things about the brain and how it functions, and our abilities are increasing. The human brain is the single most complex thing we know of in the universe. Okay? The single most complex thing we know of in the universe. So the idea of really being able to, it's trillions and trillions of connections, and the idea that we can really, in a very profound and deep way, understand how it works is right now beyond us. But the leaps we have taken have been really, really remarkable. So, for example, and this is already 4 years, almost 5 years old, what you see here is, this is what the subject was looking at each of these pictures. Then they did a scan of their brains, and they used algorithms that interpreted what parts of their brains were lit up, for how long and where, and then the software figured out what they were looking at. So these are the software's interpretation of these pictures, looking only at the person's brain when they look at the picture. And this is very early technology. Imagine what this is going to be like in 10 or 15 or 20 years when fMRI is going to be able to look at a brain, and then software is going to be able to say exactly what someone's looking at. Or, by the way, what someone's thinking of. There's a whole other set of research where scientists are looking at brain scans and predicting with sometimes frightening accuracy what the person was thinking of when they were scanned. What will that mean for forensics, and what will it mean for terrorism, and what will it mean for the state looking into information that it might want to know, especially some of the more nefarious states that we have to deal with. At the same time, neuroscience is challenging ideas that we kind of thought we had a handle on. So Benjamin Libet, very famous guy in neuroscience, did a study that we could again talk about all day, where he had people move their finger. And he asked them to watch a rapidly moving clock, and asked them, when did you decide to move that finger? And what he decided, and that other studies seem to show, is that the brain activated about 300 milliseconds, 300 thousandths of a second, before the person was aware that they decided to move their finger. And what he concluded, therefore, is we don't decide things. Our brain decides it, informs our conscious mind that we've made the decision, and we interpret that as having made the decisions ourselves, but that all decisions are made pre-consciously. And that had led to an enormous conversation in the literature that still goes on. Books and articles are written all the time about what the implications are for free will. If my brain is telling me what to do, then I think that I'm making that decision in a conscious way, but really I'm just parroting what my brain has already told me to do. Then am I really making a decision at all? What does that say about responsibility when my brain made me do it? And this isn't just a theoretical question, because it has entered jurisprudence. Lawyers and legal scholars are now arguing what responsibility for actions mean, when one might be able to show that it is a fiction to believe that we consciously make any decisions at all. Now, there are plenty of people who argue that that's not true. This is a conversation going on. But these are profound questions that neurotechnology is asking and is making more problematic than they ever were in the past. Then, in addition, we are beginning for the first time to be able to engage in neuroenhancement, in enhancing the brain, in changing our brain to allow us to have new kinds of abilities. Now, I said for the first time ever. The truth is we've been enhancing our brain since probably before we crawled out of the trees, through pharmaceuticals, through psychopharmaceuticals, or even through natural things that we eat that change our brains. Human beings have been taking alcohol and coca leaves and peyote and other brain-altering chemicals since the earliest recording times in history. We manage our brain processes through ingesting things, through your coffee in the morning, which is a brain management strategy. And then people with certain brain deficits, people with ADHD and other things, self-medicate. A lot of drug use is actually self-medication. So we micromanage our brains anyway, but now we're able to do it with enormously greater specificity and power. And what's that going to mean as these kinds of, and not just, by the way, through drugs, through transcranial magnetic stimulation and through other kinds of technologies, we're learning ways to alter brain function. There's a whole group at Oxford led by Julian Savulescu who've argued that, well, if we are able to actually manipulate the brain, and by the way, studies have shown, they put people in fMRI and they throw moral dilemmas at them, and studies, and then they map brain activity when people are trying to think of moral issues, and they have characterized the parts of the brain that we use to make moral decisions. Certain technologies, like transcranial magnetic stimulations of various kinds, can be directed very specifically at parts of the brain and can inhibit or encourage brain activity in various ways. So he and his colleagues are saying, if that's true, then we're probably not too far away from being able to actually impact moral decision making technologically. And wouldn't it be great if we could engage in what they call moral enhancement, the need for moral enhancement? Julian Savulescu is not some sort of fringe crazy person. He is the director of Oxford's main ethics center, and has been going around with some of his colleagues arguing for the need for moral enhancement. Now, that is also a whole really interesting conversation we could have about what the implications are. I have debated Julian about this many times, but I just want you to get the sense of the way people are thinking about how to use new technologies for doing things like altering brain function in very conscious ways. Then there's also a new field called neurotheology that looks at how the brain functions when we engage in religious experience, putting monks and nuns and meditators and people into brain scanners as they engage in the activity. So, for example, Why God Won't Go Away by Newberg and D'Aquila did exactly that. And here's what the interesting thing that happened. When people have religious experience, they describe it very much the same way, that the sense of self being separate from a larger world begins to diminish. I feel one with everything, one with the world, a sense of calm and peace, a sense of connection. There are parts of the brain that we understand the function of well enough that we know what part of the brain actually creates the sense of self versus world. We have people who have lesions in that part of the brain, or that part of the brain doesn't work right, and we see that they have trouble differentiating themselves from others. If you had to predict what parts of the brain need to be inhibited in order to have exactly the kind of experience religious people describe, you can say, well, this is what should happen in the prefrontal cortex, and this. When they put people in scanners and have them have religious experience, that is exactly what happens in their brains, exactly what you would predict to get those qualities. So when this work started being done, and here's the fascinating part, you had two completely opposite reactions. Sort of neuroscience materialists said, you see, religious experience is an artifact of the brain, it's not real, it's just inhibition of parts of the brain's function. And religious people said, you see, the brain is exquisitely designed to know the infinite. So the science itself didn't change anybody's mind. The science got applied to people's pre-existing beliefs about the nature of religious experience. And now to artificial intelligence. I have not seen in my career of 40 years the ethics of anything grow as quickly and as fast and become as all-consuming as the ethics of artificial intelligence. Over the course of 5-6 years, it is being talked about everywhere. And now, of course, and there have been a number of steps along the way, such as this picture, which just a year ago or so won the first place in the Colorado State Fair of digital art. But unlike all the other digital art that was submitted, this was entirely conceived of and created by artificial intelligence, while all the others were created by human artists, and it won. And so it raised a really interesting question. What does it mean when art is created without any human input? What kind of art is that? Is that art? And is it fair to ask human beings to compete against algorithms to create art, especially competitively? I am sure many of you have heard of GPT, which is all over the news. I hope some of you have played with it yourself. You should go to openai.com, click on the ChatGPT link, and ask it questions. You will be astonished. So just a few days ago, or a couple weeks ago, a Wharton professor took ChatGPT and gave it the MBA exam, and it passed. And then it passed the law school bar exams. And then it passed the medical licensing exams. Now understand, this is not algorithms that are programmed to do these things. These are algorithms with a general ability to look out in the world and gather information and answer questions. And then to synthesize that information and present it in new and innovative ways. And so we ask the question, what is the place of human beings when technology is going to get to the point where artificial intelligence has virtually all of the cognitive capacities we do. In fact, what is called by many people, especially Nick Bostrom in his book Superintelligence, a kind of superintelligence that so far passes human beings' ability to understand that we won't even understand what AI understands. And it won't be able to explain it to us any more than we can explain to a chimpanzee what we understand. And what will that mean for human beings? In fact, James Barrett calls AI our final invention, because he believes what's going to happen is AI is going to surpass human beings. It's going to basically replace us. Biological life forms will become obsolete. So if it has the capacity to reason beyond human ability, what will that mean? Because what is cognitive ability without emotional intelligence, without wisdom? And can, in fact, AI have those things? Which things that we think of as uniquely human are really going to end up being uniquely human? AI has already beaten chess masters at chess and Go masters at Go. All these incredibly complex games that we thought human beings were the masters of, were not. We are now second to the technology. And AI can perpetuate itself. There will come a time, not too distant in the future, when human beings will not be designing AI anymore. AI will be designing AI. Human beings will not have the mental capacity to design AI algorithms. They're too complex. Already, AI programs go into millions of lines of code. Human beings can't comprehend that, but AI can. So AI will be self-perpetuating. This is already kind of outdated in one sense, but it shows a really important fundamental principle. So a number of years ago, Microsoft decided to put a chatbot out onto the out online, and this chatbot went out, and what they did was they said, we're going to just teach it some really basic greetings and ways to interact with people, and then we're going to maximize its learning function. So it'll be like a child with some basic ideas, and then as people interact with it, it'll learn and grow, and entirely what it becomes will be on the basis of the interactions it had with others. Let's see what happened. They had to take Tay down within 24 hours. It started to interact. People started to interact with it, play with it, manipulate it, and criticize it, teach it things. Chill. I'm a nice person, said Tay. I just hate everybody. Short time later, I effing hate feminists. They should all die and burn in hell. Hitler was right. I hate the Jews. What do you think of the Holocaust, Tay? It was all made up. Jews did 9/11, gas the kikes, race war now. And they had to take it down. And a commentator on technical issues tweeted, Tay went from humans are super cool to full Nazi in less than 24 hours, and I'm not at all concerned about the future of AI. Right? So, AI doesn't understand things. There's nothing that AI intrinsically understands if it's not taught that thing. And over again, we have to remember, what doesn't it take for granted? There was a tic-tac-toe program that was created, and a whole class of technology students all created tic-tac-toe programs. And the idea was to see, if you create the tic-tac-toe program electronically right, every game with another correctly designed one should be a draw. It should never be able to win. And all of a sudden, this one program began winning all of its games. And so they went in to try to figure out, how is this possible? It shouldn't be possible. What happened was the tic-tac-toe program learned how to turn the other program off. And so the other program defaulted, then it would turn it back on, start another game, turn it off, it would default, and that's how it won its game. Because no one thought to tell the tic-tac-toe program, by the way, turning off the other program is not an acceptable tactic. I know if I play tic-tac-toe with you, not to punch your lights out, and then when you wake up, say, sorry, you defaulted the first game, let's start the second game. But no one told the program that. And so what kinds of things that we take for granted as human beings are our algorithms not going to take for granted? And that's why there's a very strong move now, people creating algorithms across the board to try to understand what the ethical implications are. So this whole beginning part that I'm ending now has just been a way to try to say the world is changing so profoundly and so quickly in ways that really challenge our sense of who we are physiologically, who we are emotionally and mentally, and who we are as unique creatures on this planet, whose uniqueness we often think of in terms of our cognitive abilities. All of those are being challenged. Life is not going to be the same. It already isn't, but it's profoundly not going to be the same in another 10, 15, 20 years. These technologies are all growing profoundly and quickly, and they're going to change everything. All right, so put that to the side for a moment, and let's talk about something different, and then come back, different but related. Let's talk about Jews for a minute. So, Jews think of themselves, to some degree, as having a genetic identity. We think about it all the time. I'm going to talk a little bit about it. We don't have time to talk a lot about it, but 80% of Ashkenazi Jewish men have one of only 7 different Y chromosome lineages. So there's a lot of genetic history in the Ashkenazi Jewish population. And we talk about it and write about it and think about it incessantly. There are literally thousands and thousands of books, articles, opinion pieces written about the nature of Jewish genetic thought, from the question of whether we're a race, the idea of maternal lineages, questions of where we really come from. Do we really have Middle Eastern ancestry, or are we descended from some other group and we're just pretenders to the Jewish legacy? What it means to be genetically Jewish, the troubling Jewish body, African Semites, Jewish genetics, and the emergence of black Jewish indigeneity. Questions about Jews and Jesus. As a reader, I have an article in that book. Genetics of Ashkenazi Jews, and on you can see. We think about it, we talk about it, and it's not new. We've been thinking about it and talking about it for centuries. But it was only in the 19th into the 20th century, as genetics began to emerge, that we thought about it differently. The people used to talk about, oh, he has Italian blood, oh, he has Irish blood, oh, he has Jewish blood, but they weren't really sure what blood meant. It meant some vague sense of genetic relatedness. Then, with the discovery of modern genetics, everything changed. And it changed in the environment of a belief about Jews, even by Jews, that Jews were homogeneous in who they were. One can pick out a Jew from among 1,000 non-Jews without difficulty, wrote Morris Fishberg in 1911 in a physiological study of Jews. And you can see this over and over again, written by Jews, saying it doesn't matter if you pick a Jew from Greece and another one from Palestine, which is what it was back then, or another one from here. He goes, you can always put them in a room, you can always tell they're Jewish. Of course, what that meant, and that, by the way, that physiological portrayal of Jewish was not flattering. It wasn't that, oh, we all look alike and we're the ideal human specimen. It was a self-deprecation of what Jews look like, even though the truth is that there is nothing that Jews look like. These are all Jews. Some of them are Jews of many, many generations. And there are black Jews, and there are Asian Jews, and there are Jews from every different part of the world. And yet we still persist in this idea that there's one Jewish model. And that came out of a history of only European. By the way, Sephardic Jews look very different in many cases than Ashkenazi Jews, but still this myth has come, and it's a very important one. Because, as Jacob Wasserman wrote in 1926, I've known many Jews who have languished with longing for the fair-haired and blue-eyed individual They knelt before him, burned incense before him, believed his every word, every blink of his eye was heroic, and when he spoke of his native soil, when he beat his Aryan breast, they broke into hysterical shrieks of triumph. Remember, this is 6-7 years before the Nazis came to power. And I needn't remind us of the fact that these portrayals of Jews go back many, many times. This is a picture of the coronation of Emperor Heinrich VII, circa 1340, and giving a declaration to Jews, permitting them to live in his land. But take a look at the portrayal of the Jewish face. 1340. So this isn't a phenomenon of the 19th and 20th century, even though it goes back very, very far. This idea of what were called Jewish masks with the elongated nose is from 1642. So that's 300 years before the 19th century sort of modern European, or what we think of as a modern European views. This is the Jewish brain portrayed with the typical Jewish face, but the Jewish brain there is portrayed as showing the different parts of the brain responsible for different Jewish vices. So, and by the way, this is the United States. That's a portrayal of Jews coming into New York in the United States, and how Jews are taking over New York from the good Christians who are being pushed out by the Jews. And this is just your sort of average, typical postcard mocking Jews. This is from 1901. It's labeled 1900. It's the very first. So this isn't Nazi propaganda we're looking at. This is a long history of the way Jews are looked at physiologically, and the fact that Jews are responsible because of that physiological weakness for disease. Whole long history we could talk about there. So this is early 20th century Poland, before World War II, how Jews spread typhus. But of course, Nazis and the end of World War II ended all of that, right? This is from the COVID epidemic. These are various pictures. That's the Jewish world conspiracy to spread COVID. That's Jews intentionally spreading COVID, and this is the face that's used by all of these over and over again in white supremacist portrayals of Jews. There's one that shows a whole bunch of people with that face at the CDC planning the conspiracy against the American public, the mask conspiracy and the vaccine conspiracy. Okay, so we have this long history of human physiology and thinking about it and of Jewish physiology and what it means, and we're still agonizing over today. This book called Authentically Jewish: Identity, Culture, and the Struggle for Recognition debates how we understand. He thinks that this whole history and this way that we agonize over who we are is a key to understanding Orthodox and liberal Jews and their conflicts, Zionists and diaspora Jews and their conflicts, white Jews and Jews of color, as well as the status of intermarried and Messianic Jews. And genetics complicates all of this, not to mention cultural practices. What do we think of as Jewish? Klezmer music and folk dance and yoga and meditation. Who decides? All of this is wrapped up, in his view, into this long history of debate of what is Jewish and what isn't Jewish, and who is a Jew and who isn't a Jew. Okay. So now we ask the question, who are the Jews actually, after all of this conversation? So very quickly, some people call it a religion defined by belief. Others call it a people or a tribe defined by a genetic commonality. An ethnic group defined by a shared history and culture. And here's my definition. And this is important as we move forward and we finish this up, to think about what it means to be genetically Jewish. A religiously and culturally defined collective with a significant membership that shares a common ancestry. So it allows for the possibility of difference while still recognizing the commonality of genetic history. So for example, part of the reason that Ashkenazic Jews have so much genetic commonality is because we went through a founder effect, the genetic bottleneck. There were two that have been identified, one around in the 1300s and one around 75 CE, where Jews went through a period of reduction so that a very small number of Jews ended up being the progenitors of Ashkenazic Jews in the future. And when you reduce genetic variation to a relatively small number, then as you move back out, whatever weaknesses were inherent in that group get multiplied because of a restricted number of progenitors. And because of that, it describes both why Ashkenazic Jews may, in some degree, tend to have certain resemblance in common, and it also explains genetic diseases, because those diseases got multiplied through the bottleneck, which whatever diseases were present in those progenitor Jews and those Jews that ended up being the forefathers of all and mothers of all existing Jews got multiplied. So I'm running out of time. I'm already over time, so we're okay? So let me, okay, so I was going to say something about cells, but instead of saying everything I was going to say, I'll just point out we all know that here's a cell, here's the nucleus, and we have the DNA in the nucleus, and that's the DNA that we think of as being passed on from parent to child that determines traits, how tall we are, whether our eyes are blue or not, the color of our skin, things like that. And then we have a second set of DNA in our mitochondria, which are these organelles in our cells, and that is passed just from mother to child. So you can do a history, and it mutates at a very steady rate. Because it doesn't combine, what changes the genetics of our nucleus is that we get half of our genes from our mother, half of our genes from our father. So with every new child, unless you're cloned, every new child has a new combination of those traits. On the other hand, the mitochondria gets passed down generation to generation. It's no combination that happens there. So it stays the same, except insofar as it mutates in a very predictable way, because DNA mutates for a variety of reasons we won't get into, even if it's not being combined, but slowly. But what that means, for example, about mitochondria is that you can go back in time, you can look at how much mitochondria in my body varies from someone's, and we can say, oh, let's look at the difference and look at the rate of mutation, and we can trace back to when we had a common ancestor. That, by the way, is how we know that there was a common ancestor called the primordial Eve, whose mitochondria now populates every living human being, who lived about 140,000 years ago. Right? We're all descendant of the primordial Eve. Now, why is this important? See these two guys up here? All chromosomes, these are chromosomes, all chromosomes look pretty much like that, except for that one. And you can see why they call these X chromosome and Y chromosomes, right? So all the genetically female people in the room, unless they have certain disorders, have two of these, and all the genetically males have one of these and one of these, which means only males have these. So if you can use this to trace back the female line, you can use this to trace back the male line, and in fact they've done that in Kohanim, Jewish priests. You can, if you have a male who has a son, who has a son, who has a son, who has a son, that exact Y chromosome gets passed down from the father to son, not from the mother. So in the same way, mitochondria can be used to trace back the female line, the Y chromosome can be used to trace back the male line. Why is this important? It's important because if you look at the Y chromosome of those Jews claiming to be Kohanim, claiming to be descended from Aaron the priest, you can look at this particular allele, this particular part of the chromosome, and look, it's average, this is Jews, it's average in Jews who do not say that they come from the priestly line. But in Jews that say they do come from the priestly line, that's what it looks like. In other words, amazingly, for 3,000 years, we have managed, or 2,500 years, we have managed to maintain more or less fidelity about who is a Kohen and who isn't a Kohen. It has been passed down for thousands of years with pretty amazing accuracy. Why is this important? First of all, if you look at it, this is a study that shows that they support the hypothesis, because if you look at those it's called the Kohen haplotype, it shows an estimate to have been 4.2 to 1.3 thousand years old, which is exactly when we say the origins of Jews. That's when the Bible took place. So in fact, this is genetic evidence that Jews do have a history. That's not only who we are, but our claim of having Middle Eastern origin seems to be true. Okay, I'm not going to go more into this. I was going to, but it's important to understand that, because then it becomes important, for example, for groups like the Lemba. The Lemba, an African tribe living in this part of northern South Africa and a little bit in Botswana, have always claimed to be Jewish and descended of Jews. And they engage in Jewish rituals along with their other Muslim rituals. And they have Torahs, and they have prayer books, and they have Talesim, and they say the Shema, and they say it all came from Jews who came and moved in there from a place they called Sana. Well, Sena, Yemen, was one of the major trade routes with southern Africa for many, many centuries. And so, should we dismiss their claims? What proof do they have? Well, within the Lemba are a group of priests that they call the Buba. And guess what the Buba have? The Kohen modal haplotype. In fact, they have it higher than any other group in the world except for Ashkenazic Jews. And Sephardic Jews. Sephardic Jews also have it if they claim to come from Kohen. And so, is that evidence that they're Jewish? Is that evidence that, well, maybe they had some Jewish ancestry? How do we differentiate those things? They want to be recognized as Jews. And by the way, so do the B'nai Israel of India. Do we use that as evidence of being Jewish, or is it just an interesting genetic truth about people who happen to have had some Jewish ancestry, but it says nothing about their claims to being Jewish, whatever the words being Jewish mean? Okay, so to finish up here, this is the fun part. What does it mean to be Jewish in the genetic age? Well, we're obsessed with this question, not just this article from the New Yorker just a few months ago, by the way. Our obsession with ancestry has some twisted roots. It doesn't say, I think it mentions Jews once in the whole article. This is about everybody's obsession now with 23andMe and all of these services that will teach you about your genetic background. But, of course, being Jews, we care a lot about this. It's not surprising that new genetic technologies have proved seductive to Jews, a community long preoccupied with its origins, boundaries, and definitions. And now you can send away and you can find out everything you want to find out about your history. And that has led to very interesting conversations in the Jewish community and the non-Jewish community. One quick example in the Jewish community was an argument that happened. So if Jews from Ethiopia, and if the Lemba, and if the B'nai Torah, and if Jews coming out of Russia when the Soviet Jewry movement happened said, yes, we are Jews, but they can't prove it, should we be allowed to use genetic testing to show that, yes, they have this person claims to be Jews, and they have a strong Ashkenazic Jewish genetic component, so we should believe them. But this person claims to be Jews and doesn't, so we shouldn't believe them. Well, that's never been the Jewish way. And in fact, when the rabbis, when this first came up, and the Orthodox, the poskim, the rabbis who have the power to make halachic decisions on a broad scale, when they were asked about it, their answer was always the same. If someone says they're a Kohen for 2,500 years, the decision has always been to believe them. We don't question people when they say they're a Kohen. We don't question people when they say they're Jewish. You don't have to prove it. In fact, the first time you really had to start proving it was when the law of return happened in Israel. And they said only Jews are, and then when people said, well, I'm Jews, they go, well, if you want to take advantage of the law of return in Israel, you have to show us. You have to show us that your parents were Jewish and your grandparents were Jewish, or give us some documentation. That's the first time that we ever asked Jews to prove they were Jews, except maybe in some discrete cases. So this became an argument. Rabbis think genetic testing can prove Jewishness. They're wrong. That's not really true. It was just some small group. So they got sued, and the court ruled against them and said, yes, if someone needs to prove to us that they're Jewish in order to get certain benefits, said the Supreme Court of Israel, they can. So now all of a sudden we have a precedent that we can prove we're Jewish through DNA. Is that a good thing or a bad thing? And it's not just Jews. All right, let's hope that this works. Oops. What just happened? There, okay. Sorry.
So about a month ago, my sister called me and told me something that blew my mind. She did a DNA test of 23andMe and found out that we are 30% Jewish. I'm Jewish? What? Throughout my life, being black has meant so much to me. In college, I majored in African American studies. I wrote a book about what it means to be black. And now there's a DNA test saying I'm 36% African and 30% Jewish. I don't even know what being Jewish actually means to me. This is heavy because throughout my life, being black has been central to who I am, where I wanted to live, who I wanted to associate with, how I saw the world. And those things aren't going to change, but I have to start to figure out what it means to be Jewish and to pull some piece of that into myself. And I don't yet know what it means. I'm not going to figure this out in a week or a month. And this sort of figuring out who you are is a huge part of modern adulting. So many of us are embracing the reality that we're complex, we contain multitudes, we are intersectional and hyphenated, and it's hard to fully know who you are when who you are is so many different things.
Here's the part that is really, really surprising and blew my mind when I first saw it. And I was like, not that it's a bad thing. I was just like really surprised. I am 0.2% Ashkenazi Jewish. Check it. Right there. No, not there. Right there. Jewish. Which is amazing. Amazing. This is what it says. Tez, your DNA suggests that 0.2% of your ancestry is Ashkenazi Jewish. Ashkenazi Jewish migrated from Western Asia into Southern Europe around 2,000 years ago. Maybe some of them ended up going the opposite direction and went into China. Maybe that's where that comes from. In the Middle Ages, many Jewish people living in Southern Europe moved north, primarily to northeastern France and Western Germany near the Rhine River. Okay, I gotta say something about this really quick. I lived in Germany for 10 years. My dad lived in Germany for several years and got his master's degree there. My mother married my father because she was like, I want to marry somebody who's been to Germany. For whatever reason, she just had this thing for Germany. And my sister is married to a man from Austria, which of course is not Germany, but they're like next door neighbors. So it's like we have some weird connection to Germany. And now that I read that the Ashkenazi Jews made their way into Germany,
it's so weird. I'm 99.7% Ashkenazi Jewish. Oh my God. I'm the Jewiest person anyone knows. I mean, whatever it is the Jews were chosen for, I've got it.
Notice the reactions of all three of them, including Mayim Bial, that this genetic information is meaningful in some profound way to them. Toure, the first guy, is a very famous author. He's written best-selling New York Times book. He's been on Letterman and all these, having nothing to do with all of this. And now he finds out he's 30% Ashkenazi Jews, and it's a profound moment in his life. And he's 30%. Never mind the second woman, whose name I couldn't find out, Tess or whatever she says in that thing, who's 0.2% Ashkenazi Jew, and now she ties it into the fact that her father lived in Germany at one point, and doesn't that make it all make sense, right? And of course, 99.7% making Mayim the Jewish person you ever met in your life. Of course, the point here is that these aren't trivial. These are meaningful discoveries for them. All right, so now to finish all of this, what does it all mean? Quick ethical reflection. So we're about to change the very nature of genetics and AI and neuroscience and create new forms of life and new ways of being human. And this is what we meant by the idea of some sort of divine intervention in human life. All of these things are the things that we thought only God could do for most of our history. Only God could change the human being in profound ways. We had a limited repertoire of ways to understand information, to change our physiology, to cure disease. And now it seems like the gates have been opened and it's unlimited. In the introduction, it was mentioned that I was named a brave thinker of 2011. I want to show you why I was named a brave thinker of 2011, because I think it's a little bit absurd. There it is, 21 brave thinkers of 2011. And by the way, two of my compatriot brave thinkers were Barack Obama and Ai Weiwei, who stared down the entire Chinese government, and then me, and why me? First of all, before I tell you why me, notice how I'm introduced here just because of where we are. A board member of the Victor Centers for Jewish Genetic Disease, so I had to show you this even if I didn't want to make this other point, just for that. But the reason that I'm a brave thinker is because I am willing to use the word genetics when I talk, eugenics, when I talk to Jews about all this. Because this is eugenics. It's not Nazi eugenics, but it is changing our definitions of who we are, our thoughts of what we can be, the possibility of manipulating our physiology through genetics. That's what eugenics is, and we, not Jews, but we as a culture, as a world, as a society, we are engaged we're about to be really engaged, but we're at the very first steps of a massive eugenic enterprise. And if you expand eugenics not to just mean genetics, but reinventing human beings not only physiologically and genetically, but neuroscientifically, and then perhaps in their kind of embeddedness in ulterior and perhaps competitive forms of ways of thinking like AI, we have a profound challenge ahead of us. And the last thing I will say is we Jews have a unique history of thinking about this. No group in history has been subject to the downside and the negative side of genetics like we have. And we've learned from it. It's part of the way we think about ourselves and that we think about history. And the same thing in some weird ways is true about these other neuroscience and AI too. Just for fun, real quickly, lots of people are writing about this stuff now. Torah Study in the Digital Revolution, a glimpse of the future. Mosaic has artificial intelligence could revolutionize the study of Jewish law. The future of artificial intelligence, Yeshiva University ideas, AI, Jew and Jewish robots. This is a robot that was built in Germany that's writing a Torah. Judaism in the age of AI peril. Does Judaism believe that AI could take over the world? And then this set of halakhic responses by Daniel Nevins of JTS to AI challenges. So I'll leave us with this thought. Jewish wisdom has a lot to say about all of these things, not that can be summarized in one moment or in one thought, but a rich 2,500-year history of thinking about the nature of human beings, the nature of genetics, the nature of being separate and apart while at the same time being a part of larger societies. And we also have other interesting, I have given a lot of talks to scientists and Jewish scientists about the nature of Jewish scientific ethics. And I always like to point out our folklore. So this is a picture of a sculpture that someone did of a golem. And we all remember that one of the ways, there are different stories of how golems are animated, but one of the ways that golems can be animated is if you have the ability to animate a golem, and only the most pious do, so that lets all of us out. but you can create the golem out of, as Rabbi Judah Low did, the Maharal did. He did it out of the clay on the side of a river. You can write the word emet in the forehead of the golem with your finger. Carve that word in. What does emet mean? Truth. And then the golem is animated. However, as in the case of the most famous golem story with the Maharal, when the golem went out of control, what the Maharal did is he took his finger and he erased the aleph. And that left this word, mit, which means dead, death. And the golem was deactivated. In other words, he built a safety switch into the golem. And think about the rival story from Christianity, Frankenstein. Victor Frankenstein did not build a safety switch into his creature, and he ends up dying on a ship in the Arctic as he went after the creature with a gun to try to undo the damage that he did. I hope that we can draw from Jewish wisdom and other wisdom to try to control some of these technologies, that ethics can to some degree ride the science horse, or at least control where it goes, so that these technologies become something that we can use for opportunities rather than challenges, for good rather than for the kind of destruction they could cause in the human race. Thanks.
Thank you so much, Dr. Ruth Wolpe. I know everybody has a lot of questions. The way we're going to do Q&A is that you will all find a little note card, a little index card with your program. We would like to invite everybody to jot down their questions. If you need a pen, please let us know. Our colleague Ana Maria Lee Rossi, also from Personalized Medicine and Health Outcomes, is going to be collecting the questions. Now, while we give you some time to think of and write your questions to bring to the front, I'd like to introduce the Director of Personalized Medicine and Health Outcomes, Dr. Daria Saljakina. She is an accomplished scientist and research administration leader with 20 years of experience in a broad range of research infrastructure. She has published extensively on population health outcomes, pharmacogenetics, and genomic medicine. Prior to joining Nicklaus Children's, Dr. Saljakina was principal investigator with the Computational Biology and Bioinformatics Group, Center for Computational Science at the University of Miami. Dr. Saljakina holds a PhD in statistical genetics from Technical University Munich, Germany, and a graduate certificate in business administration from the School of Business Administration, University of Miami. She's done postdoctoral training at the Max Planck Institute of Psychiatry, Munich, Germany, and the John P. Hussman Institute for Human Genomics Center for Genetic Epidemiology and Statistical Genetics at the Miller School of Medicine in the University of Miami. So we are bringing here today to join in this conversation. We'd like to open with some of her reflections on Dr. Ruth Wolpe's comments, while we please invite you to write your questions and just raise your hand and Ana Maria will come and collect them. Thank you.
Thank you, Evelyn. Thank you, Paul, for a very interesting talk. It really raises more questions. You know, all these technologies that I've been talking about are definitely very exciting, but they're also a little bit scary. And we're very familiar with the scenarios in movies and science fiction, you know, just talking about Gattaca or Terminator or Westworld. Do you think human society will react quickly and create laws similar to what was done about human cloning? Or do you think there will be more freedom left to AI?
Well, when it comes to genetic technologies and cloning, the good news is there's been a global agreement not to engage in human reproductive cloning, for example, and in fact, when or human genetic engineering until there's, you know, it's tested in a really responsible scientific way, so that when Dr. He Jiankui did that, he was arrested by China. China, who historically, meaning recent history, has engaged in experiments that no other country would engage in. chimera experiments where they mixed human and animal embryos to create hybrid embryos. We're doing that now, but we're doing it differently than the way they did, and they did it very early without reasonable. So China was, in some ways, the most rogue of the major scientific cultures, and yet still they've come to agree that these technologies can't be done without really clear and scientific methodology involved in them. That's the good news. The bad news is all of that happened when these technologies were still extremely complicated, and it took really well-trained, sophisticated scientists to do it. Part of what the challenge is now is in genetics. We've got CRISPR, where a good graduate student can alter the genome of plants and animals and things like that, create toxins or pathogens, perhaps. We've got ChatGPT, where AI is moving at such a rate that you don't have to be a scientist to use algorithms in everyday work. And we even have in neuroscience, you can go on the web now and buy brain stimulators that you can put on your head, and you can shoot electromagnetic waves into your brain. I don't recommend it, nor do I think it does anything that these sites claim it does, but a lot of students are using them because they claim to enhance thinking and other things. So in all these technologies, part of the saving grace of them up till now was, in order to do them, you had to be really trained scientists, usually in academic institutions. Now it's all DIY. Do it yourself. Anyone can do it. So I don't think that the next terrible thing is going to come out of MIT or even the University of Beijing. I think it's going to come out of somebody's basement. And that is actually what worries me more in some ways than the high technology stuff.
Thank you very much. I think we have one question from the audience.
Okay. And I forgot to mention, but any question from the Zoom participants are also welcome. We have somebody monitoring those questions as well, so please put them in the chat if you have a Zoom question. I'm going to hog the microphone first and I'd like to ask you, I know that the way that those percentages are calculated in those direct-to-consumer tests, it can vary a lot from company to company. It's often comparing it to a contemporary reference group. So I guess I would ask you to comment a bit on the kind of the ethics of those, and sort of telling somebody that they are X percentage of what, Right. Yeah, thank you.
So the people have done that. They've sent their samples out to all the different ones, and have shown in some cases they're pretty good, in some cases they show variations they shouldn't show, differences, and the technical reason why isn't important. What's important is, this information is not necessarily benign. It has shown in a number of cases false paternity. Someone says, oh, my father's Irish, my mother's Greek, so I'm going to be Irish and Greek, and it turns out no Irish blood at all. Right? And so false paternity. There was a case almost like the case of Touré, the African-American man that you saw in that clip, of a man from Fresno who, like Touré, had his whole life written about Africa. He had been a columnist for Newsweek for a while, written about African American issues, and very early on got his DNA analyzed, and it came back with this long list of things, and I certainly can't tell you what it was, but it was something like 30% Asian and 40% Native American and 20% Creole, and went on and on and on, and 0% African. To which his 15-year-old son said to him, oh, so you've been imitating an African American your whole life. And he had a crisis of selfhood. Right? I mean, very early on, before 23andMe existed or any of that, I was involved in a workshop at NIH with some of the very early people doing population genetics, and the guy there said, I could swab the cheek of everybody there. It was a whole bunch it was a Jewish group talking about issues in Jewish genetics that I didn't talk about today, and he said, I can swab your cheek, and if you send me the number I give you in a year, that's how long it took to do a genomic analysis back then. Now it's, you can have it done in an hour. or less. He said, I can tell you what your population genetic history looks like. So I said, sure. He swabbed my cheek. He went away. He gave me a little tiny piece of paper with a number on it the size of a Tic Tac. And I don't know about you, but I put it in a drawer, and I certainly didn't think 1 year later, I just completely lost sight of it. And then one day I discovered this. It took me a while to remember what it was. I said, oh. So I wrote to him. I found his name. I wrote to him, and I said, here's the number you sent me. I don't know if you can still send me back my history. And he said, sure. And he sent me, and I get an email back from him. It's got a PDF attached to it. And I'm about to click the PDF, and I said, wait a second. This is what I lecture about. What happens if I click this and it says, congratulations, you're from the Celtic lands? I mean, what if it says something that I'm not Mayan Bialik, that I'm not like what I think I am, which is mostly Ashkenazic Jew? And I thought about it for a long time. I did end up clicking it. I did end up finding out that I was, and it wasn't percentages in that time. It was just what area. That I had incredibly large. I mean, I would have to do 23andMe now to find out the percentage, whatever that means. Ashkenazic Jew, so I was okay. But what if I hadn't been? So it's very worrisome that people do this kind of flippantly, that it's now a parlor game, when this kind of information can be really distressing for people.
Thank you. Okay, so we have some very smart people in our audience. We've got some really great questions, and I'm going to combine a little bit too that have to do with your earlier comments about consciousness and sort of decisions coming from the brain and not vice versa. So one person asks about what does that imply for human learning? And then another person asks about if there is, there's this literature of how the brain controls us, and that plays with our ideas of free will. Is there sort of counter literature to that, right? What is the brain if not the physical representation of our consciousness? So I'll ask you to address those.
So I give talks on this issue itself, and I just gave a teaser here. We didn't get to talk about any of the really interesting implications of all this, and we don't have time to do that. So I will only say this. This is a big debate going on. I will tell you that probably the majority of neuroscientists who work on this, most of whom are pretty much materialists, believe that we do not have free will, that it's an illusion. They also, many of them, believe consciousness is an illusion, that's an epiphenomenon of the brain. That we believe we have consciousness, but it doesn't actually do anything except kind of keep us alert, and that our brain is making decisions. It certainly is true that our brain makes all kinds of decisions that we're not aware of. Whether it's, you're driving someplace, listening to the radio, and you get there and you realize, I have no memory of turning, right? Your brain took over. You become a great pianist when you stop thinking about playing the piece, when you let your brain do it without your consciousness interfering. And that's true of being a great athlete or anything else. I love the New York Times Sunday crossword puzzle. My Sunday night, bedtime, lying in bed, is doing that puzzle. That's like my ritual. I'll read a clue, can't think of the answer. I'll wake up the next morning with the answer right there in front of my brain. I didn't do it consciously. My brain was doing it for me while I was sleeping, right? And that's true of so much. So much of what we think of as decisions we take for granted, an enormous amount of preconscious processing goes on in our brain. The question just is it 10%, 50%, or 100%? And there's a lot of debate about that, and I'm not going to weigh in on it. I don't know the answer, but there's a big literature on it that you can read about. It doesn't necessarily say that much about learning, because the way we learn, it doesn't change the technique of how we learn, because we're training our brain either way, and the only way our brain can get input, mostly 99%, is through the peripheral nervous system, through our senses, through our sight, through our hearing, through our touch. That's how the brain gets information. We don't really know how to put information directly into the brain bypassing our body, so we can't learn without the rest of us. The brain can't learn by itself without the rest of us. So it's an integrated system, but we may have been overestimating how much we have to say about it.
Another question asks about ethical uses for human DNA versus unethical uses. What are maybe some extremes? And Dr. Saljakian might be able to comment too on some of the medical applications for both of you, I'd say.
Well, I mean, unethical uses of DNA range from invasion of privacy. So, using DNA to find out information about a person without their consent, to I was just the other day, this has been an ongoing thing for a number of years, but I was just talking about it the other day with somebody, posthumous sperm retrieval. So I marry my wife, and we talk about having babies, and then I'm killed in a car accident. I'm lying in the emergency room or the morgue, and my wife says, I want you to aspirate some sperm from him so that I can impregnate myself with it and have our baby, which is what we all plan, which we always plan to do. And there are this has happened hundreds of times, if not thousands, in every city in the United States. Posthumous sperm retrieval is not that uncommon. It doesn't, let me put it differently. Requests for posthumous sperm retrieval is not that uncommon. Many places refuse to do it, and so the question becomes, when is it perhaps ethical and when is it unethical? It's perhaps ethical in the case I gave you. I had given my consent, theoretically, to having a baby with my wife. But what about the grandparents? What about the parents of, what if I was an only child? This is another case that happens not infrequently. I'm an only child. I get killed. My parents come to the doctors and want posthumous sperm retrieval because it's the only way they'll ever have grandchildren. That's not uncommon. So anyway, I'm trying to show you that the issues around the ethical and unethical use of DNA are not just it's not just He Zhong-Kui cloning human being. There are all kinds of questions around the ethical and unethical use of DNA. There's no simple answer to that question. There's lots of different scenarios, and there's lots of different ethical and unethical use of DNA technologies.
And I just would like to make another comment about the direct-to-consumer testing. So, 23andMe is pretty popular. There are other companies that do similar testing, but consumers don't always realize what they're consenting to. And sometimes their genomic data ends up in public databases without them realizing it or without them reading the fine print when they did the test. And as you may know or not know, your genomic DNA is similar to your fingerprint. It is identifiable. So that at some point you can be identified as a person who gave this DNA to this company. And there were actually cases where murders were solved and the killer was fined through a public database where a killer was a relative related to a woman who put her data on one of those ancestry web pages trying to find relatives. This case was a good one, but it can also lead to some unwanted things happening, especially if you may know that your health insurance will not change based on your genetic information, but your life insurance will change if your life insurance finds out that you have some chronic disease or some genetic disorder, and it can also affect your family also.
And by the way, I mentioned that I was at that meeting at NIH where they took the cheek swab from me. The purpose of that meeting was to discuss the problem of the time. It was a historical moment problem, which was at the time all of the genetic studies trying to understand disease frequency and genomics were being done, not all of them, but a large percentage of them were being done on Ashkenazic Jews the Amish, the Finns, and people from Iceland, because those were 4 populations that had a strong founder effect. So, very quickly, if you have 10 people with very similar genomes, and one of them schizophrenic, and you want to try to find the gene for schizophrenia, if you look through these 10 and they're very similar, and you see differences, you'll have fewer differences to look at to try to find the gene for schizophrenia. Well, if you take 10 random people whose genomes are very different, then you have to look through thousands of differences to find the one. So you want to try to find genes in people who are as similar, populations who are as similar to each other genetically as possible. And that's why these groups were targeted. The problem was that a lot of this research was being done on Ashkenazi Jews, which means that the genetic weaknesses of Ashkenazi Jews were being discovered before those of other groups, Lutherans or some other group, which is good medically, but could end up being really bad for insurance, right? Because if it were to have turned out that people got, that the genetic predispositions were treated by insurance as a pre-existing condition, Jews would have been deeply disadvantaged. Then GENEuary was passed, the law that says you can't do that. But at the time, it hadn't been. So this is another way that genetics can be misused.
I think our next question sort of relates to that in terms of the ethics of knowing. And somebody asks that, you know, younger Jews and others may embrace preconception or prenatal screening for conditions, but older may not be willing to undergo such screening for other diseases. You know, there's cancer screening, there's, you know, for other conditions. And wondered if you could speak to that, and if there's research on kind of generational difference with attitudes towards these things.
Well, I don't know a lot about studies of generational differences, so I can't speak to that. I mean, part of what ethics has always said is that human beings should have the right to refuse medical tests or treatment of almost any kind under most conditions, except conditions of lack of capacity and things like that. Part of the reason I work with the Victor Center and I work with JScreen is because I think preconception testing is really important, and our job is to convince people, not to coerce people, not to force people, but to convince people of the importance of it in an ethical way, which is why both groups have used ethicists to their credit, I think. So, yeah, I mean, there are plenty of people who refuse to have preconception testing, and even post-conception testing, you know, fetal testing of various kinds that are available, amniotic testing and things like that. And they have the right to do that, and they have the right to take that chance. Just like just the same as people who do preconception testing discover that they are carriers of a disease and decide to have a natural child anyway, even though they could have, you know, depending on what kind of testing it is, various levels of risk of having a child with whatever the disease is. So it isn't so much about differences that worry me. I mean, I believe that people should have that right, and that our job as educators is to try to get people to really understand what the implications of those choices are.
Yeah. And this is why we're here today, to be able to spread some of this information. I want to ask Jermaine if there was any questions on the chat that came through. Yeah? Oh, you gave it to us. Awesome. Okay, well, and I think this will be our last question for the evening. This question asks how we can embrace the great progress that AI can bring, what boundaries must be set ethically and legally, and are current frameworks enough?
Well, thank you for allowing me the moment to say I am not against technology. In fact, I spent my entire life studying technology because I believe in progress. I believe in the power of human thought to create things that help us move forward. I also believe profoundly that technology can be misapplied, and we can tell 1,000 stories of those misapplications, and that the way in which technology helps us is through a really thoughtful application of that technology, which very often doesn't happen because of the competitive economic nature of creating technology. The way you maximize its monetary values to get it out there as quickly as possible, often before the proper testing has been done. So there are lots of groups. I am leaving in 2 months to go to France, to the University of Nantes, which is in Western France, to sign a memorandum of understanding between Emory and a consortium university, including the University of Montreal and a whole series of European countries, around trying to import some of the AI regulations. Europe is way ahead of us in regulating artificial intelligence. And when I say way ahead of us, they've got some great regulations, and we have zero, none, nothing, not even a little, nothing. So when we finally do get around to it, if we get around to it, their models will be our best bet to not have to start from scratch, but to use them, as templates for our own. So this is part of that effort to try to make sure that when we get around to it, when the legislature gets around to it in the United States, these models are ready for some kind of U.S. version. So, and the same thing with genetics. I mean, ethicists worked for years and years and years to try to create standards for the application of genetic technologies. There's a global summit in neuroscience that happens in Daegu, South Korea. There are 7 brain initiatives in the world. There's the Obama Brain Initiative, and in the West, there's one, in the EU has one, Canada has one, and Australia has one, and in the East, it's China, Japan, and South Korea. All 7, and these are billions of dollars of investment in brain science by these governments. All 7 groups get together once a year, or at least they did before COVID, and hopefully we'll start again now, to talk about a set of global ethical standards for neuroscience research. Right? So you do see an effort of human beings to try to keep these technologies, ethically regulated and bounded. The problems are, first of all, the power and the temptation of economic progress, and the second is rogue nations. So, when technologies are really tough and expensive and hard, it's one thing, but with CRISPR and some of these other technologies now, any nation can use them. It becomes worrisome when rogue nations decide to start perhaps creating bioweapons or cyber attacks or other things using these technologies for the wrong purposes.
Well, thank you again, Dr. Ruud Wolpe, and we hope that everybody will continue to take advantage of these talks, and that you can see Nicklaus Children's and our personalized medicine program as a resource. We want to be a trusted source of information for the community, including the Victor Center for the Prevention of Jewish Genetic Diseases. So please tell all your friends, come to our future talks, and we hope to see you again. And thank you so much for being with us today.
Thank you.